Okay, now that we have a little bit of the concept behind limits, we want to start getting to a more formal definition or looking at actual functions themselves. So here's three different kind of interesting functions. They all have the equations underneath them. And notice all three of them are undefined at x equals 2. So in this one, we can see they just plucked this point out, so the function exists everywhere except for that point. This one, we have this big jump or discontinuity. And then this one looks like, if we think back from college algebra, it has a vertical asymptote, looks like at x equals 2, which would line up with the function 2, right? If you're looking at the domain of this, you see you can't plug 2 in because you'd be dividing by 0. Same issue here, same issue here. But for the limit, we want to take a look at the points around them. So say on this very first function, if just eyeballing the graph, we can see that when we plug in x equals 2, right, we can't do x equals 2 because it's undefined, but we can kind of see that if we did points really close to it, it seems to be getting closer and closer, right? Like this point exists, we can get as close as we want. It seems to be the outputs getting closer and closer to 4. So if we wanted to write that using our limit notation, what we would write is the limit, so LIM of f of x, just saying which function we're talking about, is 4 as x approaches 2. So as you get closer and closer and closer to x being 2, the function value gets closer and closer and closer to 4. In a little while, we'll look at some more special cases, like the next two are a little harder to nail down because you can see right from the beginning that if you come from one side, it looks like it's approaching one value, and over here it's approaching another. So that will mean something slightly different, but just to get used to function notation. So another thing we can do to work on our kind of intuition of these, or especially if we have a function that is difficult to plug in, right? This one might have been a little bit easier to see. One thing we can do is just experiment with it numerically. And the easiest way to do that would probably be to use the table on your calculator. So if you go to your calculator and you pretend like you're going to graph this function, and you don't have to use this little fraction menu to type in fractions, but sometimes I like to because it saves me parentheses. All right, so we put our function in here. If we wanted to graph it, it should look something like this. Now you notice like you don't really see this open circle on here. It's not that it's not there, but your calculator is just doing individual pixels. So if it just skips one little pixel, you're never going to notice. But where we probably will notice is if we go to the table, see how we get to x equals 2, it says error, because we knew from the beginning, right? 2 is not in the domain of this function. And so we can't plug 2 in, but we can plug in any points. Now your table defaults to doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want to explore numbers that are really close to 2. And so one good way to change this is if you go to table settings, so second window, and we change our independent variable, our x, to ask instead of auto. So instead of automatically filling it in, we get to type in values. So then picture if we're trying to get closer and closer and closer to 2, we want to try stuff like 1.9, 1.99, 1.9999, and obviously we know 2 is going to cause an error. And then we could try stuff that's a little bigger than 2. And you'll get your kind of own method on this. But if you're looking for a pattern, it does help to kind of go in order. So see how this is numbers that are below 2, and I'm getting closer to 2. And then these are numbers that are above 2, and so I'm making it get further away as I go. So totally up to you, but you can also see the pattern a little easier. See how my output is 4.1, then 4.01, then 4.00001, and then I can't plug in 2. And on this side, same thing, I can see it clearly approaching 4. I get 3.9, 3.99, 3.9999. So sometimes they'll talk about looking at a limit or experimenting with a limit, they call it numerically. It's also a really good fallback if when we learn other methods, if you're stuck and you're just not sure if the limit's working out, it helps to go back to the table and you're just essentially experimenting. Like what happens when I make my inputs get close to 2, what happens to the outputs? Even on one that's algebraically possible, it sometimes helps to kind of know the answer or get an idea if there is an answer before you even start. And so there's our kind of first look at trying to explore limits numerically.